Okay, I know these are not your favorite problems, with the exception of a few of you who said in class, I love to do these. You, my friends, are in the minority. Okay, so I'm going to start out easy. Don't get too excited. There are, let's say there is at least one on the test that is this easy, but it's also in the minority. Sine of x times cosecant of x equals 1. And what they're saying with this problem is, they're telling you the answer. So that's the easiest one. You'll know if you have it correct if you get to this as your final answer. We're going to leave this side alone. But also they're saying that if I pick any value on the unit circle, or any angle at all, it doesn't have to be just ones you memorize, like pi over 8 isn't on the unit circle. It's not one of the ones you memorized, but it's on the unit circle. If I found sine of pi over 8 times cosine of pi over 8, I don't even need to do any work. I know the answer is 1. So sine of x times, this is me proving it, I know cosecant is 1 over sine of x, and yay, we're done. Okay, that's easy, right? So let's do one more that is that simple. Sine of x times cotangent of x equals cosine of x. Again, I know that I need to replace cotangent. And cotangent is the same thing as cosine x over sine of x. And once again, one step, we have cosine of x, we are done. But you know that they can't stay this easy, so let's get a little bit harder. And this one can actually be done in two different ways. I am going to do it the easier way first, and then I'll do it the awful way. So sine squared x minus tangent squared x over tangent squared x sine squared x equals -1. Okay, you guys love the concept of just crossing things off. Like you want to cross this off and this off. But when you're adding and subtracting, you can't just cross off. If it were multiplying, I could. Like if I had sine of x times cosine of x divided by sine of x times cosine of x, these things could just go. But that's not what I have. What this is saying is sine squared needs to be divided by all of this, and then tangent squared needs to be divided by all of this, and then I have to subtract. Okay, again, this is the easier way to do this problem. There are always many ways to do these problems, but this is the easier way. So I have sine squared x all divided by tangent squared x sine squared x minus tangent squared x divided by this whole thing. Yay, I can cancel things off. And you know there's a 1 left up here, right? There's a 1 left here. So I have 1 over tangent squared x minus 1 over sine squared x. And you know that 1 over tangent squared is cotangent squared. And you know that 1 over sine squared is cosecant squared. And you also learned that there is a relationship between cotangent squared and cosecant squared. You know that cosecant squared minus cotangent squared is 1. But that's not quite what I have. I have the backwards of that. I know that cosecant squared x minus cotangent squared x equals 1. And I have the opposite of that. So I can factor a -1 out of here. And isn't this the same as -1 positive cosecant squared x? This is a basic property of mathematics. Minus cotangent squared x. And now I have what I want. This is 1. So -1 times 1 is -1. I'm done. Now at this point right here, this is one of the ones that I told you if you recognized was -1, you could have just jumped to this step right here. Okay, let's do this one the tough way. Ugh. So I have sine squared x minus tangent squared x all over tangent squared x sine squared x equals -1. Okay, I don't like seeing tangent squareds. Like, I like sines and cosines better. So I'm going to change both tangent squareds to sine squared over cosine squared. Ugh. So sine squared x minus sine squared x over cosine squared x all over, this is a big fraction, sine squared x over cosine squared x times sine squared x. So let's see. Up here, I'm adding two fractions. In this case, I'm subtracting two fractions, adding a negative. So I need to get a common denominator. So if I'm just looking at this part up here, I know that the common denominator is cosine squared x. So I have to multiply top and bottom by cosine squared. So let's see, I have sine squared x, cosine squared x, and let's see, multiply top and bottom by 1, so -1 times sine squared x. Ugh. Then in the denominator, sine squared x times sine squared x is sine to the 4th x divided by cosine squared. Okay, wrap your head around that. Sine to the 4th x over cosine squared. Up top I got a common denominator, cosine squared x. I had to multiply top and bottom by cosine squared, top and bottom by 1. Okay, so the next thing I'm going to do is some algebra. I see that I have a sine squared x here and here. I can factor that out, right? Oh, or would you rather multiply by the reciprocal first? Let's do that. Yeah, that's better. Maybe not better, but it's something to do. So I have sine squared x cosine squared x minus sine squared x all over cosine squared x times the reciprocal of this, cosine squared x, you know what I'm thinking when I say reciprocal. And that means, yay, I'm multiplying, so those things can cross out. Now, the next thing I can do, I see that I can factor a sine squared x out of this. So sine squared x. If I factor a sine squared x out of this, I'm left with cosine squared x. And if I factor a sine squared x out of this, I'm left with -1 all over sine to the 4th x. Now remember, we've talked about this, and this is on that paper that I had yesterday. I know that sine squared x plus cosine squared x equals 1. Well, cosine squared x minus 1, let's see, I'm going to subtract 1 from both sides. So I have sine squared x plus cosine squared x minus 1 equals 0. And then I'm going to subtract sine squared from both sides. So I have cosine squared x minus 1 equals negative sine squared x. So cosine squared x minus 1 is the flip. It's the backwards of 1 minus cosine squared x. So we've talked about that. So this is negative sine squared x. I told you this was the hard way. Sine squared x times sine squared x is sine to the 4th x negative all over sine to the 4th x, gone, -1. Okay, that is the more difficult way. Okay, I'm going to give you now 3 problems, and I am proposing this in the form of a contest, and I forgot to bring the prizes today. I will bring them tomorrow. So the first person in your class who can get all 3 of these done, I will bring you something tomorrow. Like candy. Don't get too excited. It's not that valuable. First one I want you to do, and I'm not even telling you what this one equals. I'm just telling you it reduces nicely. So this is 1. And then this is 2. This one I'm going to make you prove. I'm going to tell you what the answer is, so you'll know if you have it right. And then for the third one, let's give you this one. This one's hard. Okay, this one's tough. But these are the 3 problems. The first person in each class that gets them done and brings them over to my room to show me, I will give you a prize tomorrow.